When you first knew that you would be attending a water damage course, you may not have considered that there would be a section on microbiology. However, water has unique qualities that are essential for all living things. Where there's life, there's water. So when water enters a building, the opportunity for life to flourish also begins. The problem is, much of the life that begins to thrive is not stuff we want in buildings. Microbial growth, specifically mold and bacteria, can take place very quickly when the conditions are right, regardless of the other conditions such as temperature and surface. And the addition of water will amplify growth of microorganisms with time. What that means is that water needs to be removed immediately and completely throughout all areas and assemblies of the building to stop the growth of mold and bacteria. Also, once water's gone, there's no need to worry that mold will come back again in the future unless water enters the building again. Mold and bacteria are primary concerns of building owners and occupants. So naturally, there's a section entitled The Microbiology of Water Damage. So, how are we feeling about the microbiology of water damage?
That sounds like where I get off the bus. I am not great with science.
Yeah, I totally get it. And there's a lot of information in this section. It's probably one of the longest in the entire course, but we're going to work hard to keep this as simple as possible. Let's talk about our goal. Our goal on water damages is that they be clean and dry, in that order. Clean first, then dry second. And there's two primary cleanliness concerns on water damage: mold and bacteria. Now, mold and bacteria are everywhere, so just their presence is not necessarily a problem. But given the right circumstances, they could become a huge threat to people's health. And water damages provide just the right circumstances.
Okay, so I know things can get mold when they're wet, but is drying enough? Should we spray something to stop the mold? Like, where's the bacteria coming from? Maybe that's too many questions, but I just get concerned when it comes to people's health.
Well, I'm glad to hear that you're concerned, and we're going to answer all of those questions. However, let's start with why microbial problems in a water damage is a concern. There are two ways, again, that water damage affect the indoor environment as it relates to mold and bacteria. First, dirty water can bring in contamination from flooding or sewage. And second, if things are not dried properly or they're allowed to remain wet for too long, we wait too long to get started with the drying process, then mold and bacteria can grow and become a problem. IICRC standards define contamination in two ways. Wet contaminant levels are defined by category, and mold contamination is defined by condition. So we're going to follow that pattern and take the microbiology section in two parts. Number one, mold, and number two, water. So we're going to be looking at the wet contaminants like bacteria, viruses, and other pathogens when we talk about water. First of all, though, let's begin with mold. The IICRC S520 standard for professional mold remediation defines mold contamination levels in three different conditions. You can find those definitions in your student manual. To discuss those conditions, let's kick this over to our science correspondent, Nerdy Nick, to help us out. What can you tell us about conditions, Nerdy Nick?
Oh, it's my turn. In the mold remediation standard, the S520, indoor environments relative to mold are sectioned into three conditions. You have condition one. That is a normal fungal ecology. An indoor environment may have settled spores, fungal fragments indeed, or traces of actual growth, whose identity, location, and quantity are reflective of a normal fungal ecology for a similar indoor environment. Then you have condition two. Condition two, this is settled spores or fungal fragments. This is an indoor environment which is primarily contaminated with settled spores or fungal fragments that were dispersed directly or indirectly from a condition 3 area. Indeed. Now, this may have traces of actual growth. Now, condition 3, this is actual growth. This is an indoor environment contaminated with the presence of actual mold growth, associated spores, and fungal fragments. Actual growth includes growth that is active or dormant, visible or hidden.
Okay, so thank you for that condescending delivery, Nick. Nothing makes you feel like both an idiot and a better person at the same time, like listening to Nerdy Nick. Let me make a brief recap of what he just said. Condition 1 has mold spores, but a normal level of mold spores, and it's not considered contaminated. Condition 2 is contaminated by higher than normal levels of mold, but you won't see it because it's contaminated by settled spores and could also include minimal growth. And condition 3 is actual mold growth that you're going to see growing on materials. It would also include mold growth that would be hidden, like inside a wall cavity, also condition 3. So both conditions 2 and condition 3 are considered contaminated. Now, let's shift to how water damage can contribute to mold growth. Mold needs a few things to grow, but it's the addition of water that's changed in this environment. So the water is what we're going to focus on to stop mold growth.
Would it be safe to say that if we were finding mold on a water damage, it most likely came from that water damage?
Not necessarily. Mold growth can be a result of water damage because we've added water, but it also could have been the result of another moisture-related problem that was there before the water damage that we're there for. That's why rapid response is so critical. Once we begin drying, though, we need to be concerned about getting moisture content levels low enough so that mold and rot won't occur in the affected materials after we leave. Mold will grow on materials that have a moisture content at or above 16%. So, our drying goal would always be below 16%.
Point of order there, Jeremiah. I'd like to add a critical fact that you failed to add to the discussion. Yes, mold can begin to grow at 16%, but additionally, wood rot fungi can start growing at a moisture content at or above 20%. Very important. So obviously, you would always dry materials to below 16% before considering them satisfactory. But make a note of the fact that above 20%, you could have wood rot fungi growing.
Thanks, Nick. I was just about to say that when you interjected.
I'm making note of that. I know we haven't discussed how dry the materials have to be in order to consider them dry yet, but I think what he said was an important point. Wood rot fungi can start growing at a moisture content of 20% or higher. And obviously, we wouldn't want to leave the materials at 16% because that allows mold growth, which is one of our key microbial concerns.
Now that's at the end of the job. As I mentioned at the beginning of the job, to reduce the likelihood of damage and microbial growth, restorers should begin mitigation as soon as safely possible. When water is added to an environment, we get what's called a shifting ecology. And it's a shifting ecology because the variables have changed. We've added water, and that's an important part of what mold needs to thrive. And there are 5 requirements for mold growth. Number 1, you need elevated moisture content materials, above 16%, right? Number 2, relative humidity that's greater than 60% is like miracle grow for mold. It's going to grow really fast in those conditions. The third thing is temperature. But temperature control alone is not going to stop mold growth because different molds grow at different temperatures. However, the molds that we most commonly see on water damages, sometimes they're even called water damage molds, grow best between 68 and 86 degrees Fahrenheit. The fourth thing that mold needs to grow is stagnant air. So before you begin to see mold growth or visible mold growth, which would be condition 3 mold growth, then we want to get lots of airflow going. When we first get to a job site, if there's no visible mold, get airflow moving. Once mold starts to grow, we don't want airflow. And the fifth thing mold needs to grow is time. The challenge with time is affected by the other factors. The more water and relative humidity, and the better the temperature, the faster mold's going to grow. So we're addressing all of these things early in the job to reduce the likelihood of microbial growth.
So let me ask you this. What about when we find mold already growing on a water damage? I've heard different things about what we're supposed to do.
Great question. And I'll answer your question with a question. What's our first concern when working on a water loss?
Well, clearly the health and safety of the workers and the occupants.
Exactly. So the first thing to do is put on the appropriate PPE. We don't want to go any farther with the work without protecting ourselves. As soon as we've protected ourselves, we start protecting the indoor environment so that it's safe for others. That'll mean putting up engineering controls. Well, what are engineering controls? You may recall in the hierarchy of controls, it's a safety measure that is above PPE on the chart. And in this case, the engineering controls that we will use will be air filtration devices and negative pressure. When we use an air filtration to create negative pressure, we can call it a negative air machine. Sometimes you'll hear that term used. It's the same device, but it describes the way we're using it currently. Some people call the same machine an air scrubber. But again, let's use the term air filtration device instead. However, if there's condition 3 or active mold growth that you can visibly see, what's the best course of action to take?
Well, at the beginning of this, you said to clean first and dry second. Based on that, I would guess that we would prefer to clean up the mold first.
I am an excellent teacher because that is exactly the right answer. Preferably, we would remediate the mold before going any farther. But you're not always going to have qualified mold remediation technicians on the job site. Or for other reasons, you may want to wait to do the remediation until a little bit later. There could be reasons such as waiting on an indoor environmental professional, which we also call an IEP, waiting for them to do an assessment, or waiting on an insurance adjuster or other materially interested party to authorize payment of the remediation. There's often delays that set us back before we can start the remediation. So what do we do then? Well, we move to the next principle, which is to begin mitigation or drying as soon as possible. So we can begin with initial humidity control, and this humidity control could be installed even before remediation is complete. But initial humidity control means we install dehumidifiers to manage humidity, not install air movers. Anybody want to guess as to why we wouldn't install air movers?
Yeah, we don't use air movers because it starts blowing the mold around and makes the situation worse. We could blow mold from one small area to another throughout the whole house if we set air movers, and that creates cross-contamination.
That's right. Mold spores are very light. Even small amounts of airflow will make them airborne. And now we're just blowing them all over the indoor environment. So in the case that we need to wait to do remediation, and we need to begin mitigation or drying services first, in the areas that have visible mold growth or mold contamination, we would only use dehumidifiers, not air movers. Additionally, when you're going to go this route, make sure your containment is right to the mold. In other words, put the plastic directly over the moldy areas.
Yep, that's exactly how we're doing it too.
Okay, and that's as in-depth as we're going to get about mold. If you really want to get into mold remediation, IICRC has a lot of courses that go into great detail. But now let's talk about our second microbial concern on water damage, which is water contamination and wet contaminants.